Good morning, everyone. My name is Jennifer Amah. I work as a senior software engineer for a green energy company based in Germany. Today, we're going to talk about an interesting topic in the AI space, and it's about if you should use gRPC in your AI tooling stack. Over the last couple of years, AI has exploded. We've moved from building models in notebooks to building products that people rely on every single day. And with that shift, something becomes very obvious. People don't just care what the AI says, they care how it feels. If it lags, if it cancels slowly, then the magic is gone. And that is where the question comes in. Should we be using gRPC to build these AI systems? For some people, gRPC is already the default. But for most, it's like an unnecessary complexity. So in this talk, I want to unpack that with you. We'll look at what gRPC does, the problems that it solves, the trade-offs that it brings, and finally, when it's actually the best tool for your stack. So what is gRPC? gRPC at its core is just a framework that lets services talk to each other. But the way it does it makes it really fast. Instead of using JSON, it uses protocol buffers, which are much more smaller and more efficient. And because it's built on HTTP2, you get things like streaming in both directions and handling multiple calls at once. The simplest way I like to explain it is this. REST is like sending a letter through the mail. One message, one reply. gRPC is like being on a live call, where both sides can speak and listen at the same time. So what does it matter for AI? Over the last years, gRPC has moved from research labs to large language models, multimodal systems, image generators, and many more. They are not just research projects anymore. They are powering products people use every day. And with that, expectations have changed. People don't want to wait. People want answers instantly, streamed as they are being generated. That's where gRPC comes in. It's fast, it handles streaming really well, and it scales across multiple calls. That's why it's become the go-to tools for team serving AI models at large. This chart shows gRPC maintains constant, low latency performance as the number of AI models and concurrent calls scale up, making it for real-time AI workloads. When you look under the hood of every AI tool, there are a few common stages. A user sends some input, maybe text, voice, even images. The model processes it and generates a response. Sometimes it has to call an external API or a database midstream to fetch extra information. Meanwhile, a streaming resource back to the user as they see progress as it happens. And finally, a user gives feedback or even cancels midway. Each of these stages we just looked at has its own pain point. Code starts are brutal. That first request takes ages because the model has to spin up. Then there's token latency, where the model just trickles text slower and anyone has patience for. 2 calls mid-response can be sluggish and break the flow. Streaming isn't always reliable, so the user could catch themselves staring at a frozen screen. And maybe the most frustrating, when a user hits cancelled, the system keeps chewing out compute away. That wastes resources and money. If you've ever used an AI tool and felt like it was slow or responsive, chances are one of these problems was to blame. Now, for each of these problems, there are possible solutions for them. For cold start delays, you can warm start the model so the first request doesn't seem like you're waiting for water to boil. Another is efficient token streaming, where you send each token the moment it's ready, so responses feel alive. Then there's bidirectional tool calls. Instead of stopping the AI to make an API call, you can handle it on the same channel without round tips. And finally, instant cancellation, which means the moment the user steps out, the system actually stops. These aren't abstract ideas. They make the difference between a clunky AI demo and products people actually enjoy using. There are two critical moments in AI interaction where performance really matters. The first is when the AI needs to call a tool mid-response. Even a small delay that can make the conversation feel broken. With gRPC, you get a single bi-directional stream. So responses can flow back instantly without waiting for a whole new connection. The second is cancellation. When a user decides to stop, you want everything to shut down immediately. Otherwise, you're wasting compute time and burning money. gRPC has built-in support for cancellation that's fast and reliable. Those two things alone can completely change the experience, especially at scale. Here is a simple example. Imagine a client app talking to a gRPC client, which calls an Amah service that runs the AI model. Everything can go through an API gateway to manage traffic. The nice part is that gRPC keeps the flow efficient. Requests and responses travel on the same stream, so you don't need extra overhead. It's a clean, practical setup that shows why people reach for gRPC in production. This is a simple AI code reviewer powered by gRPC. What I want you to pay attention to is how the feedback doesn't just appear all at once at the end. It's that the suggestions are streaming in as they are being generated. That means while the model is still thinking, the user is already seeing useful hints about their code. This kind of real-time feedback makes the experience feel interactive and alive, instead of stop and wait, and that's exactly the kind of smoothness gRPC is built to deliver. But let's be real. gRPC isn't perfect. Setting it up takes more work. You need protofiles, code generation, and extra tooling, which can be a lot for a small team or quick prototypes. Browsers don't support it natively, so if your product is browser heavy, you will need a gRPC web proxy, which adds more moving parts. Debugging is also harder compared to plain HTTP, and messages aren't human readable, so you will need an external tool to do that. And honestly, if your tool only makes occasional JSON requests, gRPC can be an overkill. So when does this make sense? gRPC really shines when you're streaming responses in real time, making frequent mid-response to calls, when cancellation needs to happen instantly. That's the sweet spot. On the other hand, if you're building something simpler, maybe a prototype or a browser-first app or a system that only makes occasional lightweight calls, REST are often a better fit. It doesn't have to be either either REST or gRPC. It can be a mix of both. You can use REST where it's simple and bring in gRPC where performance really matters. The key is picking the right tool for the right job. And thank you for listening. The goal here is not to convince you that gRPC is always the answer, because it's not. But to give a clear framework of when it actually pays off. I'd like to hear your own experiences. Have you used gRPC in your AI stack? How was it, and what was the experience? Any questions on that? No question? Thank you.
Hi, my name is Igor. Do you have any data show an improvement when transitioning from JSON REST protocol to gRPC? Like any cases that you looked at?
Sorry, come again?
So any data from the real life project, what is improvement when transitioning? Like, by how much latency was reduced, et cetera, et cetera?
Yeah, so for latency, it takes a lower time. I can't give it in figures, but when you use JSON, it actually takes a longer time to return the response compared to when you use gRPC with protocol buffers. But then there's a side to this because it is not necessary to use gRPC, or it's not necessary to use the protocol buffers instead of using JSON when you're dealing with just text. I think the difference in the latency is significant when you are dealing with JSON objects. We are dealing with JSON instead of when you are dealing with text. So I would say that it doesn't really make sense to use gRPC when the data that you're expecting are mostly text, but it's better to use it when they are JSON. Not sure if that answered your question.
Yeah, I was kind of looking for specific numbers because I would also expect for text, I guess compression would kick in on the transport layer anyway, right?
Yeah. There's a difference, but the difference happens when it's at scale. So when you're dealing with large data over time, you see the difference. But definitely, when you use protocol buffers, it is much more faster than when you're dealing with JSON.
Yeah, I was looking for numbers. How much faster?
Thank you. Any questions?
So I'm curious, when you listed out the downsides of gRPC, which one would have kind of the biggest positive impact if it were addressed?
Okay. Could you mention one of the downsides?
So I think you had limited browser support, debugging overhead, and being overkill for simple apps.
Yeah. So I would say the browser side will have more impact. The reason is that with the browser, you might not experience as much performance that gRPC has to offer if you're using the gRPC web proxy. But aside that, if you're using gRPC without the web, it is much more faster. So the browser side definitely has more downside. So if your app is browser heavy, if it's something that maybe it's a browser first app and on the surface, you don't want to use gRPC there. But then, like I mentioned in the verdict, it can be a mix of both. You can decide to use REST from the browser side and then introduce gRPC where you really need to focus on performance. Yeah, please.
Someone's asking about latency number comparisons. There's a lot of data online, but the comparison is that gRPC is about 7 to 10 times faster at scale than doing a REST call. So,
Is that a question or?
no, I was just trying to provide
Okay.
information to the earlier question.
Okay.
So,
That's why it's like deep JSON hierarchy or something.
yeah, if you're comparing systems that are using REST JSON,
It's server to server, right? Not browser to server.
yeah, servers to server. Yep.
Okay. So I was actually expecting a question about. Okay, you can go on.
It won't be the right use case. So
Possibly.
I just want to understand, like, when would you, like, are there cases where you should be using gRPC when your app is on a browser, needs to be served on a browser, or you just don't recommend using gRPC there?
Yeah. So I wouldn't recommend using it if your app is browser heavy. because it just adds more complexity. You have to use gRPC web proxy, which is not as fast as when you're not using gRPC web proxy. But also, you can use both of them. And scenarios where you want to use gRPC is where performance is very important and you want to make mid-response call. So you're calling the model, you want to reach out to an external API call, you want to use gRPC in these cases because of the bi-directional streaming that it gives you opportunity for. So that way you just have one open connection and that makes it better. But then, yeah, you can use gRPC on the browser if you want, but I mean, it's like an overkill. It's like over-engineering at some point, but it's better to just introduce the both of them.
But will it degrade the performance?
It would not be as fast as if it weren't on the web. I think the web makes it a little bit slower. I don't have the figures to back that up, but using gRPC web proxy would not give you the speed that using gRPC without the web does. Yeah. Okay, so I was expecting a question about WebSockets because I spoke more on streaming. And there's always this debate about streaming, like, oh, why not use WebSocket? WebSocket can do that, you know? And as much as WebSocket can also handle streaming, I think there are some special cases where gRPC has power over it. Because if you mention WebSocket, that, oh, WebSocket does streaming, gRPC does streaming, why would I use gRPC using WebSocket? But when it comes to cancellation, I think gRPC has like built-in features for cancellation that makes it faster. Unlike when you're using WebSocket, I think you still have to do more logic on that in order to cancel quickly. And canceling quickly is very, very important because if you don't cancel well, when the user decides to end the call, there could still be some background processes going on. So it's very important to have something that helps you cancel quickly. Any more questions? No questions, no questions, no debate. But how many of us has used gRPC here? Okay. How many of us have used gRPC web proxy? Okay. What do we think about the experience?
So yeah, our use case it's just for connecting an existing application to use the gRPC interface. So latency is not that much of an issue.
Okay.
So yeah, we chose to use gRPC on our embedded system, but there were existing web interfaces, and so we used the gRPC gateway or the web proxy.
Okay. So, but do you feel it's complicated using it, or it's just something you just add to it?
No, it's not like, because you don't have to change the gateway for every API that you add. It's automatic. So it was easy to set up. Okay, cool. Nice to know. Has everyone used gRPC to build an AI tool here? Okay. What was your experience? Yeah, you have a question? You're just waiting. Okay. What was your experience in terms of streaming? How did it work? Do you think it was better using gRPC?
I can share our experience. So we are doing server-side streaming. We're doing server-side streaming. The server is a Python gRPC server.
Okay.
And it's streaming server to another backend, basically the backend for the front end. The backend is doing a proxy, Envoy proxy.
Okay.
And front end is consuming directly gRPC stubs. So it's actually using gRPC in terms of server-side streaming. And latency-wise, other than the LLM responses, so the latency of the LLM itself, it's comparably better than REST, I would say.
Okay.
So technically, we can do SSC as well, right? So server will stream events to the backend of the front-end server, and that backend can do SSC to the front end, only to broadcast events to the client. This is not going to be bidirectional, but it works really well for us. But we did not pick up the SSC pattern.
Okay.
We just deployed a Envoy proxy, which is proxying all the requests directly to the client and back and forth, right? So So that's the experience. So far, I don't think we have run into any major hurdles yet, but it's only deployed to a very limited number of users. So when we will ramp it to more users, I guess we'll observe more data and patterns.
Okay.
Yeah.
Cool. Thank you. Yeah, please.
So do you know if there are any managed LLM services, just like Gemini or OpenAI, which are like moving towards providing a gRPC interface in addition to the REST API?
No, I'm not aware of this. Well, thank you. I think someone must answer that.
Quick question in regards to cancellation signaling.
Yeah.
I don't have to do anything as software engineer, right? It's in SDK
Yes.
of gRPC, right?
Yes.
So it gives like more stable connection
Yes.
comparing to WebSockets, right?
Yes. So for gRPC, I think each of the languages, they have their own pattern of calling the method to cancel. So you just cancel immediately, other than, for example, WebSockets, where you need to do some extra logic to get that done.
Just like a follow-up to that, on the server that's going to be receiving the cancellation request, you were saying that the server doesn't have to be like polling for that or like identifying when that happens? Because at least my assumption would be like the server would want to know like at a specific point it might be able to cancel versus when it cannot. So you're saying the server doesn't do any sort of that logic, it's just automatic?
When you talk about the server, are you talking about when you try to cancel from gRPC?
So if we have a client calling
yes.
a gRPC server, and so the client initiates a cancel request,
Yes.
are we saying that the server doesn't have to have any logic to listen for that or respond to that? It's just automatic in the framework?
Yes. So gRPC handles that for you. So when the client cancels the request, behind the scene, you call the function to cancel it, but it does it immediately. So if you don't have an extra, if you're using something like, for example, WebSockets, or maybe just REST, you're using a REST architecture, when the client cancels, in the background, the AI will still be running. Because you already made a request to go to the model. So the model will still be running in the background. So this is like spending money you don't even need. The user already canceled. Like, just waste compute time. Like
a follow-up to that.
Yeah.
So if that's happening automatically, what might happen? Let's say a backend request has multiple steps. Maybe the first step makes some like update, and then a second step maybe makes another update, and there's a cancel in between those. If the server doesn't have to have any logic for that, how would like the first step get rolled back in that example if it gets canceled between the first and the second call?
Are you talking in within a single connection? Like
Right.
this first call and second call are all happening in the same connection, right?
Right. So like let's say the backend API, and it's going to make 2 update calls, right?
Okay, so if you're streaming and this is happening in one open connection and you cancel, it cancels automatically. What is it talking about?
Single request.
Oh, okay.
This request makes 2 outgoing requests.
Okay.
Like, deduct money from one account, move them to another account. 2 separate transactions.
Okay.
You receive cancel in the middle.
I don't think it would work in this case if you're making 2 different requests and then you cancel. I think it only cancel the one that you canceled.
It's a single request.
Yeah, but I mean,
2 database transactions.
okay.
So I think the reality is you need server-side support for
cancellation
installation.
token, right?
It's not free.
Of course, but like it's as simple as handling cancellation token, I guess. You have cancellation token if you're watching. If it's canceled, then it's up to you what to do. Of course, it doesn't cancel transactions. You can, at least you know, as a developer, that other end canceling.
Yeah, it's like preemptive multitasking. You need to look for, oh, am I being
You
canceled?
still have to.
Okay, I'll stop working now. But it's not, there is no magic.
Sure.
Server-side developers have to work.
It's
on
just
this.
tools for you to make more efficient
I think you need to handle the events on the server side. You
Yeah.
have like rollback, right?
But it was the same story with WebSockets
Yep.
years ago, right? You just send a message, you need to look for it in the stream if you get it.
So just
It's
like
just
the
standardized
channel has
protocol.
on-connected, on-disconnected events that you can
Yeah.
handle on the server side, there's also on-cancellation. So you need to write your code in the on-cancellation and start rolling back your database commits. I think that's what you were talking about, right?
Right.
Okay, I hope your question was answered. Okay, if we don't have any more questions, I think that will be it. Thank you everyone for listening, and see you.